Hello everyone. So let us solve the next type of problem. So it is like analysis of the symmetric frames when the line of symmetry passes through the columns. Okay. So you can see here, analyze the given frame by Carney's method. Given that the moment of inertia of all beams is twice that of the columns. So again, they have not mentioned in the diagram, but they have just give it in a form of statement that the beams have moment of inertia twice as that of the column. So if column is I, the beams would be 2I. Okay. All right. So in this given frame, you can see here, um, it is a complete symmetric frame. Now you can see here, this one, A, B, E, and F, this is called one bay, B-A-Y. Okay. So next, this is F, E, H, G. This is called as the second bay. So first, if you move horizontally, okay, there are horizontal frames as such, then it is called bay. If the frames go vertically upward like this, then that is called story. So this is now two bay double story. Okay, single story, double story. So two bay, two story. All right. Okay. So you can see here. So CDJ is carrying a UDL, and BEH is carrying a UDL of 90 kilonewton. This is 60. Okay. So now again, it looks, the frame is quite big, but that doesn't mean you have to solve it completely. So here you have to use a method that is called as axis of symmetry. Okay. Axis of symmetry. So what we do here is, now see here, due to the symmetry, the joints on the line of symmetry do not rotate. Because it is symmetrical, see here, if you cut the section exactly D, E, and F, and you flip this over, it's still going to look the same. That means it is symmetrical. So it is symmetrical along the line and along the column, that is D, E, F. So because it is symmetrical along the line of symmetry, here, due to the symmetry, the joints on the line of symmetry do not rotate, and hence they may be treated as the fixed ends, and only one half is analyzed. So these are all treated like fixed ends now. D, E, and F, they're treated as fixed end. So only we're going to treat the left side of this. So the left side of this only we'll consider. So because it is symmetrical, even the right side would be same. So now the modified frame looks like this. You can see here A, B, C. Okay, at D becomes fixed because they don't rotate. E also becomes fixed because they don't rotate. Okay, so we'll consider only left side of this. All right. So only this we are going to solve now. Okay, now see here. B connects BA, BE, BC. Likewise, C connects CB and CD. So these are the only two joints which we are going to use and find the rotation factors. Okay. All right. First, as usual, find the fixed end moments of all the members. So fixed end moments of first AB. Okay. Again, AB, BC, DE, EF, GH, HJ. Okay, these are columns which do not have any forces acting on it. Because it does not have any forces acting on it, so here the moments will be 0. Okay, next, MFCD. Okay, so MFCD is equal to MFDJ, okay, which is equal to minus WL square by 12. Okay, and similarly, here MFBE is equal to plus or minus MFEB. So it is again WL square by 12. So these are the only moments which we're going to find out here. Okay. We're going to only solve half of it because of its symmetry. Because solving this becomes very tedious. Okay. So we have to make the use of symmetry and solve this. Okay. So once you find the moments, next is a joint finding the rotation factors. So first, BA, BA, BE, BC. Again, all are fixed supports. So all are fixed supports. So it is 4EI by L. 4EI by L. Okay. So whereas in beams, it is I becomes 2I. Okay. So that you have to be careful here. Then similarly, BC, 4EI by L. CB, 4EI by L. CD, 4EI by L. Okay. Right. Next, find out K. Then summation K. Summation K and for joint B, summation k for joint C. Okay, now rotation factor. So rotation factor is equal to, okay, so it is this, fine, minus half k by summation k. So find all of these and be careful when you're finding the rotation factor. It's better you write the formula here. So it is minus half k by summation k. So that time you remember that you have to multiply it with minus half. Okay, so all are minus. All right. So let's assume this. Okay, the same figure, I'm going to redraw this and highlight B and C joints. Okay, so we're going to highlight, so joint C and joint B. Okay, again, as usual, write A, E and D joint like this, fixed. Okay, then okay, now C, fine, write the fixed end moments at C and D. So it's minus 125 plus 125. Here also minus 187.5 plus 187.5. Okay, so then add this. So when you add this and this, there is sum of moment at the joint at C. So it is 125. Here there is no fixed end moment, 0. So it is minus 125. Similarly, minus 185.5 minus 187.5. Again here no moments. So it is again minus 187.5. Okay, then whatever you have found out here, all these B A B C, mark here, B A B C, B E B C right here. Next C B C D right here. Okay, next start the iterations one by one. Okay, when you start, again, always you should start from the left top corner. Okay, so that is from this side, like this. C, again there is nothing at D. Again, of course, there's nothing at E, then come back to B. So it is C, then B, C and B. Like this, you should go on calculating the cyclic iterations. Okay. So first you should always start with C and then go like this clockwise. So C minus 125. Okay. So this is minus 125. Then at far end B is the far end, but there's nothing you have to find at, you have this because the first step we have no moments at B. So it is minus 125 into minus 0.273. Okay, so it is belonging to beam, just write it below the beam. Then this belongs to the column, so minus 125 into minus 0.227, write it here. Okay, so first iteration is over. Now C is connected to B. Okay, now because C is connected to B, so write this, it is minus 187.5. Okay, so to the far end of B, which is connected to C, is this, we have already calculated. Okay, so it is 28.375. So minus 187.5 plus 28.375. Okay, so answer, whatever answer you get, into minus 0.169, write it here, minus 32.461, write it here. Okay, then minus 0.2127, write it here. So first iteration is over. Okay, now again come to joint C. So again in joint C, minus 125. Now we've already got the moment at the far end B. So it is minus 125 plus, okay, this moment, because C is connected to B with this moment. Okay, so it is minus 125, then plus 26.89, okay, into minus 0.227 into minus 0.273. Write it here. Over these two moments you have calculated. Now come to B again. So again minus 187.5. With respect to this, far end is this now. 22.27 into 0.169. Write it here. Into 0.204. Write it here. Again into 0.127. Write it here. Okay. So again carry out these iterations. Okay. So here you'll end up, here this is 27, 27, 22, 22. So this, here you end up early. So it is like in the third step only you get the answers, which is, it doesn't make much difference. So this is the time where you need to stop. Okay. So now these are moments of, so this is BA, write it below only, then it is easy for you to understand. This is BA, this is BE, then this moment BC, CB, and this is CD. Write it below here. Okay. Next is you have to directly calculate the moments. So we know that the formula to calculate moments is MAB is equal to fixed end moments. Okay, so at A there is no fixed end moments, so 0 plus 2 times near end plus far end. So 2 times with respect to A, near end is nothing here, there is no moment, but far end is 21.013, so it is answer is 21.013. Similarly BA, same thing again, fixed end moment in B, here there is no fixed end moment, here no forces, no fixed end moment. Okay, at B. Plus 2 times near end. So 2 times near end is this. So 2 times 21 plus far end is this. Far end is 0. Okay, it's 42.02. So like this you have to go on calculating. Same thing for BE, hmm, BE, BC and CD. Okay, DC, CB, all this you have to calculate. So the formula is simple. So it's fixed end moments plus 2 times near end plus far end. Okay. All right, so once you calculate this, so next is just mark all the forces in this. Okay. So always you should recognize if they give you such big problem, so you have to find that axis of symmetry if that exists or no. So if the line exists, then things become simple, then you have to only find moments at joint B and C. All right. Okay. All right, that's all for today. Thank you.